Okay, everyone, we are nearing the end of chapter 6. All the new material is covered, and now we're going to look at how to apply it to real life situations. As with before, whenever you're looking at a question, you're trying to decide whether you're looking for the zeros or whether you're looking for the vertex. And how do you tell? Well, the lazy way is if you're looking for the maximum or minimum, you're looking for the vertex. If you're looking for anything else, you're after the zeros. Now, how do you find the zeros? You can factor still, or use the quadratic equation. Now, of course, pretty much every question that we're going to be looking at this chapter is going to require the quadratic equation, but that doesn't mean you can't look at it to factor. Um, we had a whole other method, but completing the square is considerably easier and faster than what we have been doing. So that would be the ideal for finding the vertex. Um, just a heads up, in this chapter, I will expect you to use quadratic formula. Actually, you don't have much of a choice. There is no alternative to quadratic formula. But I will expect you to use completing the square rather than the method that we've been using in chapter 4 and 5. Okay, so you may as well just get in the habit of it anyways. And quite frankly, it's easier. So why would you do it the longer and harder way? Now, make sure you understand the question. Are you looking for the vertex or are you looking for the x-intercepts? We covered that a little bit, and it's still true. Some of the work that some of the equations will have the variables defined for you. If the variables aren't defined, then you are going to have to do it. If the question doesn't tell you how to solve, then choose the method that you think is the best. I will not accept graphing under any circumstances. Um, but otherwise, unless the question specifies, you can probably choose. Yes, I did just finish saying that you have to use complete the square, but frankly, some of the questions, if you found your x-intercepts, it might be easier to continue on that way like we did in chapter 4 and 5. Sort of depends which one's the easiest way. Anything flying through the air can be modeled by a parabola. So as long as it's not a rocket, like something that's flying through the air under only the influence of gravity, will follow a parabola. It becomes a big thing in physics. Look at your answer and does it make sense? Now, this one, I don't expect you to do the math in your head, but you should be able to look at your answer and go, all right, I guess that could work. So for instance, if you throw a ball up in the air, you would expect that your quadratic equation that you would be able to find two roots. One might not be a real root, right? It might be negative time, but it does hit the ground. If you come up with a solution with no roots, it does suggest that you've made a mistake somewhere and you're going to have to go back and see where the mistake is. Finally, of course, it's a word question, so it should have word answers. So here we have a model rocket shot straight up shot off a roof. The height in meters, time is in seconds, and there's the equation. What is the height of the school? One of the bits of information that we do get from standard form is that it is, well, you get the starting value. So in this case, 15 meters. What is the maximum height of the rocket? So since we're looking at maximum, vertex, complete the square. All right, so although technically there's nothing wrong with how it's written, I'm going to rewrite it out in a way that we're used to looking at it so that we can complete the square based on that. Neat. Not sure what happened there. How long does it take for the rocket to pass a window that is 10 meters above the ground? So since we're looking at the height of 10 meters, we replace the h with a t, or with the height. And now we got to solve for t. However, we can't do it with the number 10 there. Has to equal 0. And we have done this previously, but just in case, now we can use the quadratic equation. Notice it's a t. I don't recall if this has come up in the homework or not, but since we're using a t in the equation, we are not solving for x, we are solving for t. This should be cool. This one's not possible. Not sure why I'm having such a hard time. Cool. Anyways, negative time means that that answer is not possible, and this is where your therefore statement comes in. Both of these are mathematical answers, but only one of them is a realistic answer to the question that was asked. When does the rocket hit the ground? Well, this is essentially the same question that we had before, except that now we're working off the original equation. Um, 48, 15. Okay. Nick has a rectangular garden which measures 3 by 3. And he wants to build a walkway around the outside. If you want the area of the border to equal the area of the garden, how wide should it be? So we know that area is length times width. And in this case, there's two areas. In this case, we don't know what x is, but we do know that if we put it in, we can solve for just the outside. Sorry. All right, so there we go, right? Because we have the area of the big thing minus the area of the inside. 3 times 3 is 9x minus 9. I'm going to be a little lazy here. Divide by 3 is 2x squared plus 3x minus 3. All right. What is that? 8 times 3 is 24, positive 24. Uh-oh. What does it say? It doesn't say how many decimal places, so 0.7 meters wide. All right. Last one, and I'm not going to go through. Before I get too far, I forgot to do this. I made the equation. The variables are not defined. I had to put them in there. Product of two consecutive numbers is even numbers is 5624. So I'm going to use x. Okay, so it's the sum. Oh, sorry, the product. So that means times. So it's going to be x times x plus 2 equals 5624. 24. I'm solving for x. I will come along and finish this up in a minute. I'm at 60 minutes right now, and I'm willing to bet that more than a few of you are falling asleep. So if you're good with this, here's your homework. There's nothing under Jokey Smurf. And if you're not good with this, I'm going to finish it up right now. Okay, guys, that's it for today. Hopefully tomorrow will be a shorter lesson. Amazing how long this one was without anything new into it. Just remember to keep everything straight. We're using the skills that you've already got and apply them appropriately. And remember, no using the quadratic equation while trying to cross the street. See you guys.